It happens without warning. One moment you are asleep. The next, you are simply awake. No alarm, no sound, no reason you can point to. You check the time. It is almost always the same window, somewhere between 2 and 4 in the morning. The room is silent. The world outside is silent. And yet your mind is now fully, uncomfortably online, running through tomorrow, replaying yesterday, circling a thought you were not thinking about 10 seconds ago. You lie there. You wait. You try the usual tricks. Nothing works the way it's supposed to. And somewhere in the waiting, a quiet, familiar thought arrives. Something is wrong with me. Here is the first thing worth knowing tonight. Almost certainly, nothing is wrong with you. What is happening to you at 3 a.m. is happening in some form to nearly every person on Earth, most of whom never mention it because they assume, exactly like you, that it is a personal failure. It isn't. It's biology. And by the end of this, you'll know something else too. Something about this exact hour that used to have a name. Not a diagnosis, an actual name, used by ordinary people for centuries. We'll get there. But first, the biology, because the name won't make sense without it. There are 4 separate things happening at once in your body during that window. 4 systems on 4 different schedules, quietly overlapping in the same narrow stretch of night. Once you see all 4, 3 a.m. stops looking random. Let's start with the first one, and it's hiding in a part of sleep almost nobody thinks about: the shape of sleep itself. Sleep is not one long, uniform state. Most people imagine it as a single block. You go under, you stay under, you come back up. That's not what the architecture actually looks like. Sleep is built from cycles. Roughly every 90 minutes, the brain moves through a sequence of distinct stages: light sleep, deep sleep, and REM sleep, the stage most associated with dreaming. And then, at the end of each cycle, it rises almost to the surface of wakefulness before diving back down into the next one. 4, 5, sometimes 6 of these cycles happen in a single night, one after another, like a slow tide. At the top of each cycle, that near-surface moment, you are not fully asleep and not fully awake. For most of the night, this moment passes in seconds. You don't remember it. You simply sink back down into the next cycle, and by morning, you'd swear you slept straight through. But here's the detail that matters. Cycles later in the night do not behave the same way cycles earlier in the night do. Something shifts, and that shift is piece 1 of our answer. Earlier in the night, your body spends more time in deep sleep, the heaviest, most restorative stage, the one that's hardest to wake someone out of. But as the night goes on, the balance changes. Deep sleep gets shorter, lighter sleep and REM sleep take up more of each cycle. By the time you reach the middle of the night, that 2 to 4 hour window, your cycles are, structurally, running much closer to the surface than they were at midnight. Piece 1. You don't wake up at 3 a.m. because something has gone wrong. You wake up around then because that is structurally the shallowest part of the night, by design, not by accident. But a shallow moment in a sleep cycle doesn't fully explain why you stay awake, why sleep doesn't simply pull you back down the way it does every other time this happens in a night, dozens of times, without you ever noticing. For that, we need piece 2. And it isn't about sleep stages at all. It's about a second system entirely, one that manages time itself. Deep in the hypothalamus, sits a cluster of roughly 20,000 neurons called the suprachiasmatic nucleus. It is, in effect, your body's master clock, the structure that keeps nearly every organ, hormone, and cell on a repeating 24-hour schedule, synced primarily to light. One of the things this clock manages is the daily rhythm of a hormone most people only associate with stress, cortisol. And cortisol is about to explain something that probably never made sense to you before. Cortisol is often framed only as the stress hormone, but that's an incomplete picture. Cortisol also functions as an alertness signal, and under a healthy circadian rhythm, it follows a very specific curve across 24 hours. It reaches its lowest point somewhere in the early hours of the morning, and then, well before you'd normally choose to wake up, it begins climbing again, quietly, gradually preparing your body for the transition out of sleep, hours before your alarm has any say in the matter.
Here's where it gets interesting. For a lot of people, that early rise in cortisol lands directly inside that same shallow window of sleep architecture we just described. Piece 2. Two separate systems on two separate schedules, quietly overlapping in the same narrow window of the night. A structurally shallow point in the sleep cycle, a structurally rising point in the cortisol curve. When they land close together, the result is a brain that is far easier to fully wake than it is at almost any other hour. That explains why you wake. It does not yet explain why, the moment you're up, your mind doesn't feel groggy. It feels sharp, alert, sometimes uncomfortably so. For that, we need to leave the biology for a moment and go somewhere stranger. 300 years ago, in a world without electric light, this exact hour of the night had a name. To find it, a historian had to go looking somewhere nobody expected to find it. In the late 1980s and 1990s, a historian named A. Roger Eckerch began combing through diaries, court records, and medical texts from pre-industrial Europe, documents written centuries before electric light existed. And he kept finding the same strange detail, described so casually that earlier historians had simply read past it without noticing. People described going to bed shortly after dark, sleeping for several hours, waking sometime in the middle of the night, and then staying awake deliberately for an hour or more before returning to a second stretch of sleep until morning. They had names for it. First sleep, second sleep. The waking hour in between wasn't treated as a problem to solve. It was simply part of an ordinary night. A quiet stretch used for reading, prayer, quiet conversation, or simply lying in the dark with one's thoughts, before drifting into the second half of sleep. Piece 3. Eckerch's research suggests this two-part pattern, often called segmented sleep, may have been the ordinary shape of a night for much of human history. Not a disorder, a default. It's worth being precise about what this evidence does and doesn't establish, because this is the point where a claim like this could easily be overstated. Historians don't have direct physiological recordings from the 17th century. The case is built from written descriptions, not brain scans. And segmented sleep patterns aren't universal across every culture and era researchers have studied. But the documentary record is extensive enough that many sleep researchers now take it seriously. A consolidated, uninterrupted 8-hour block may be less of a biological baseline than a habit shaped by artificial light, fixed schedules, and modern expectations. Which quietly changes the question we started with. Maybe the wrong question was ever being asked. The moment of waking at 3 a.m. may not be the anomaly. The expectation that a night should pass as one seamless, unbroken block from lights out to alarm might be the newer, less natural idea. A standard that electric light made possible and that modern life quietly turned into a requirement. your body isn't necessarily failing to do what it's designed to do. It may simply be doing something closer to what it always did, inside a world that no longer expects it to. That's 3 pieces down. There's one more, and it's the one that explains the part that actually bothers you. Not the waking itself, but the racing thoughts that come with it.
During the day, your prefrontal cortex, the region responsible for reasoning, planning, and keeping worry in check, is constantly competing for resources with everything else you're doing: conversations, screens, tasks, other people. At 3 a.m., most of that competition disappears. The room is dark. The body is still. There is, quite literally, nothing else for an alert brain to process. At the same time, a network of brain regions known as the default mode network, active specifically when the mind isn't focused on an external task, tends to become more prominent. This is the network associated with self-referential thinking, replaying the past, rehearsing the future, worrying. Piece 4. The same brain that felt manageable at 8 in the evening, surrounded by distractions, can feel unmanageable at 3 in the morning, surrounded by nothing. Not because the thoughts themselves are larger, but because, for a narrow window, they have the entire stage to themselves, and a prefrontal cortex that is only partially back online is less equipped than usual to put them in perspective. 4 pieces. Put together, they stop looking like 4 separate coincidences and start looking like one ordinary intersection. A sleep cycle that is structurally shallow in that window. A cortisol curve that is structurally rising in that same window. A sleep pattern that, for most of human history, seems to have included a waking stretch in the middle of the night as a matter of course. And a brain that, once awake in a silent room, has unusually little to compete with its own thoughts. None of this means every night waking is harmless, or that difficulty sleeping never deserves attention. Some patterns of nighttime waking are connected to other factors worth understanding on their own, and persistent, severe sleep disruption is worth discussing with someone qualified to look at your specific situation. But for the ordinary, occasional 3 a.m. wake-up that resolves within 20 or 30 minutes, current evidence points less toward something broken and more toward a set of overlapping, well-documented rhythms, doing, more or less, what rhythms like this have quietly done for a very long time. Which leaves the one question we opened with, and never quite answered. Why does it feel so alarming if it's this ordinary? Perhaps it's simply this. A silent room at 3 in the morning is one of the only moments in modern life when there is truly nothing left to distract you from being alone with your own mind. For a few centuries, humans treated that hour as ordinary, a second, quieter half of the night, not a problem to be solved before morning. Somewhere in the shift to electric light and fixed 8-hour blocks, that quiet hour lost its place, and what was once simply the shape of a night became for many people a source of quiet dread instead. Tonight, somewhere between 2 and 4 in the morning, millions of people will open their eyes in the dark, at exactly the point their sleep architecture and their internal clock were always going to bring them close to the surface. Most of them will assume something has gone wrong. Almost none of them will know that for a very long stretch of human history, this hour had a name.